This is my fourth video lesson for Unit 6b. In this lesson, we'll be determining the mole ratios and the hydrate formula. Go to page 11 in the class packet. Motivation. Using this recipe of a chocolate chip cookie, answer these two questions. In the first question, what is the maximum amount of cookies that could be made if only one egg is used? So you have to use a ratio based off the recipe. So 2 eggs can make 10 cookies. So 1 egg can make 5 cookies. In the second question, how much butter is needed to make 17 cookies? So again, we had to show another ratio. So we know 2 butter can make 10 cookies. So 17 cookies, you would need about 3.4 butter. So how is this relevant? I want you to imagine chemistry is similar to cooking and a recipe is similar to a chemical reaction. So take a moment to read the passage on page 11. Notice I wrote the recipe as a chemical equation. Here are our reactants and here are our products. In the recipe, you can figure out how much product you can make based off the ratios between the ingredients. So we're going to apply this concept into chemistry and chemical equations. So check understanding number 1. If you want to make 1 cookie, how much of each ingredient would you need? Based off the recipe, which makes 10 cookies, if you want to make 1 cookie, we need 1/10 of each ingredient in the correct ratios, as shown here. Stoichiometry is the calculation of the relative quantities of reactants and products in a chemical reaction. Here's a cooking analogy. So imagine the chemical reaction is the recipe, the reactants is the ingredients, the products is the culinary dish. Stoichiometry is basically cooking with chemicals. Coefficient is the quantity of the ingredient, and mole ratios is the proportions between the ingredients and the products. So we will discuss what mole ratio is in this lesson. Learning target. At the end of the lesson, I'll be able to solve stoichiometry problems involving mole ratios and determine the formula of a hydrate. Homework number 4 will be a Junipod based off this lesson. There will be a quiz Junipod on PowerPoints 1, 2, 3, and 4. Here we have 1 mole of N2 reacting with 3 moles of H2 to give us 2 moles of NH3, or it can be 1 molecule of N2 reacting with 3 molecules of H2 to give us 2 molecules of NH3. Mole ratio is the ratio between the amounts of moles of any 2 substances involved in a chemical reaction. Mole ratio is used as a conversion factor between the products and reactants in a chemical reaction. Learning check number 1. Given the balanced equation representing a reaction, the mole ratio between NO and NO2 is what? Pause the video and resume once you complete it. So the ratio between NO and NO2 is 2 to 2 or 1 to 1 ratio. Choice 1. Now we're going to answer some questions regarding this chemical equation. Is the reaction endothermic or exothermic? It is exothermic because energy is on the product side. What is the mole ratio between N2 and NH3? By looking at the equation, it is 1 to 2 ratio. What's the mole ratio between NH3 and H2? NH3 is 2 and H2 is 3, so it's a 2 to 3 ratio. 1 mole of N2 produces how many moles of NH3? 1 mole of N2 produces 2 moles of NH3. 2 moles of N2 produces how many moles of NH3? If we have 2 moles of N2, we double the amount of NH3 we make, which is 4. 1 mole of N2 produces how much energy? So based off the chemical equation, it will be 92 kilojoules. 3 moles of N2 produces how much energy? If we know 1 mole of N2 produces 92 kilojoules, we just multiply it by 3. That should give us 276 kilojoules. 2 moles of NH3 releases how much energy? So that would be 92 kilojoules. How many moles of N2 are needed to produce 10 moles of NH3? The first step is to figure out the mole ratio between N2 and NH3. It is 1 to 2 based off the chemical equation. Next, we set by proportion. So we want to produce 10 moles. How much N2 do we need to produce? So X is the moles of N2. If we cross multiply, we get X is 5 moles. We need 5 moles of N2 to produce 10 moles of NH3. Question 10. How many moles of NH3 are produced when 3 moles of N2 are reacted with excess H2? So we have to first write out the mole ratio between N2 and NH3. That is 1 to 2. We have 3 moles of N2. How much NH3 can we produce? X is the amount of NH3 produced. If we cross multiply, we get X is 6 moles. We are producing 6 moles of NH3 when 3 moles of N2 reacts. Now try to do question 11 and 12 on your own. Pause the video and resume once you want to see the answer. Here are the answers. Loading check number 2. Given the reaction, what's the minimum amount of ammonium carbonate that reacts to produce 1 mole of ammonia? Pause the video and resume once completed. So the mole ratio between ammonium carbonate and ammonia is 1 to 2 ratio. So if we have 1 mole of NH3 produced, we have half a mole of ammonium carbonate. So the answer is choice 3. Learning check number 3. What's the total number of moles of NH3 produced when 10 moles of H2 reacts completely with N2? Pause the video and resume once you want to see the answer. So the answer is choice 1. The mole ratio between H2 and NH3 is a 3 to 2 ratio. If we have 10 moles of H2, how much of NH3 can we produce? If you cross multiply and solve for X, you get X is 6.7 moles. In the second part of the lesson, we'll be figuring out how many water molecules are in a hydrate. If you recall, hydrates are ionic compounds with water molecules embedded into the crystal structure. In the hydrate, the ionic compound and the water molecules are at a fixed ratio. When you heat up a hydrate, the water molecule will evaporate, leaving behind an anhydrous ionic compound. Anhydrous means dry. This is a chemical change because the hydrate and anhydrous ionic compound are different substances, as you can see here. The hydrate is blue and the anhydrous ionic compound is white. In this lesson, we'll be figuring out the ratio between the ionic compound and the H2O in the hydrate. We will be doing this experiment in lab. So this is the setup for the experiment, in which we'll be heating up the hydrate to remove the water and we'll leave behind the anhydrous ionic compound. We're going to first place the hydrate in a crucible. Then we're going to place the crucible into this setup. We're then going to heat up the crucible until all the water has evaporated. So currently it's still a hydrate. We're going to heat up the crucible. So the water is going to evaporate. So this is partially completed. So as you can see, some of the water has evaporated. After a while, all the water has evaporated. As you can see, the color changed completely. Check of understanding number 2. Explain why the hydrate must be heated repeatedly until the sample have a constant mass. In the lab, even though it might look like all the water has evaporated, complete color change, there might still be water left in the sample. Therefore, you must keep heating the sample to ensure that all the water is evaporated, because once all the water has evaporated, it will be a constant mass even though you keep heating it repeatedly. If you have your anhydrous ionic compound, you can convert it back to a hydrate by adding water. Now we're going to go over the calculations on how to determine the ratio between the ionic compound and the water. The procedure to do this is on page 12 on your packet. I'm going to do a couple examples. Example number 1, 13.57 grams of magnesium sulfate hydrate, MgSO4, X H2O, is heated, leaving behind a residue of 6.63 grams. What are the main and the formula of this hydrated salt? The question is describing the experiment I showed in the previous slide. Basically, you have your hydrate. You heat up the hydrate until all the water is evaporating, leaving behind the anhydrous ionic compound, which is the residue. So the first step is to figure out how much water evaporated. So we're first going to find the mass of the anhydrate and the mass of water. Anhydrate is the anhydrous ionic compound. It is the residue. To get the mass of water, we have to do the hydrate mass minus the residue mass. So this is the equation. Mass of water is equal to the mass of hydrate minus the anhydrate. Just a reminder, hydrate is the ionic compound with water. In the experiment, the water evaporated, leaving behind the anhydrate, which is the dry ionic compound. If we plug in the equation, we get 6.97 grams of water. That's how much water evaporated from the hydrate. The next step is to find the GFM of H2O and magnesium sulfate. To do that, you have to use the periodic table. The GFM of H2O is 18 grams per mole. The GFM of MgSO4 is 120. The next step is to convert everything to moles. Why do we convert to moles? Because the chemical formula of the hydrate is a mole ratio between the ionic compound and the amount of water. So we have 6.97 grams of water. If we use the equation on table T, we can solve for the amount of moles. We have to convert mass to moles by dividing by the molar mass. We get 0.385 moles of water. The next step is to convert magnesium sulfate to moles. So we have 6.63 grams of magnesium sulfate. We divide it by the molar mass, and we get 0.0553 moles of magnesium sulfate. So this is the mole ratio between the water and the magnesium sulfate. The next step is to convert both numbers into a whole number ratio. To do that, we can divide each number by the moles of MgSO4. So let's do that. Divide the moles of MgSO4 by MgSO4. You should get 1. Divide the moles of H2O by the moles of magnesium sulfate. So we get 6.92, which is roughly 7. And this is the ratio between the compound and the water. It's 1 to 7 ratio. So the final step is to write the formula and the name of the hydrate. So it's MgSO4 with 7 water molecules. So this is magnesium sulfate heptahydrate. I am going to do one more question as an example. Question 1, 100 grams of hydrated cobalt 2 chloride, CoCl2, X2O, contains 45.44 grams of water. What are the main and the formula of this hydrated salt? So the first step is to figure out what information we're given. We're given the mass of hydrate and the mass of water. So our first step is to figure out the mass of the anhydrate. This is the equation. The mass of water is 45.44 grams. The mass of the hydrate is 100 grams. So the mass of the anhydrate will be 54.56 grams. The next step is to convert the mass of the anhydrate and the mass of water to moles. So 54.56 grams of cobalt 2 chloride divided by the GFM of cobalt 2 chloride is 0.419 moles. The mass of water is 45.44 grams. We divide it by the GFM of water, which is 18, and we get 2.52 moles. This is the ratio between the ionic compound and water. To get the whole number mole ratio, we divide both numbers by the moles of the ionic compound. And this is the mole ratio between the ionic compound and the water. It's a 1 to 6 ratio. So the chemical formula is CoCl2, 6H2O. And the name of this hydrate is cobalt 2 chloride hexahydrate. Now I want you to do the rest of the problems on your own. Pause the video and resume once you want to see the answers. So here are the answers. This concludes the video lesson for today. Remember to do the Juniper homework and quiz.